We are reviewing what we introduced. So if I ask you to find the population proportion or population mean, you're going to take a random sample and find the sample proportion or sample mean, but it doesn't necessarily capture the true value of population parameter. That's why we need something else that we call the confidence interval. The confidence interval captures possible values that are estimating the population parameter. So first, you need to find the point estimate for P, which in this case our population proportion. The point estimate for P, the population proportion of successes is given by the proportion of successes in sample, and it's denoted by P hat, which is X divided by N. What is X? X is the number of successes or the number of yes in the sample, and N is the sample size. The point estimate for population proportion of failures is denoted by Q hat, which is 1 minus P hat. Next, an interval estimate is an interval or range of values used to estimate a population parameter. And now, what is the level of confidence C? The level of confidence is the probability that the interval estimate contains the population parameter, assuming that the estimation process is repeated a large number of times. Now, how do we calculate the critical value? If C is given to you, C is basically the area below the curve. And if you have the area to find the Z value, you're going to use the function inverse norm on your calculator. The level of confidence C is the area under the standard normal curve between the critical values, negative ZC and positive ZC. Critical values are values that separate sample statistics that are probable from sample statistics that are improbable or unusual, referring to these two little areas that has unusual values. You have some popular level of confidence. 90% level of confidence, the area below the curve is 90%. The Z value for it is 1.645. 95% level of confidence has critical value or Z value on the horizontal line, 1.96. And finally, 99% level of confidence has critical value, 2.575. I showed you how to use your calculator and calculate each one of these separately, but let's review that again. So you need to go to second, vars, and find inverse norm. Inverse norm, if you have the area, calculate the Z value for you. So if the area is 90%, 0.90, mean must be 0, standard deviation must be 1, and you must be on the center of your graph. So when you click on paste, you get your critical value, which is 1.6448, or as you can see, it's rounded to 1.645 on the right-hand side and on the left-hand side. Again, second vars, inverse norm, if you have a different area or confidence level, or like 95%, mean must be 0, standard deviation must be 1, it must be located at the center, and when you click on hit enter, you get negative 1.9599, and on the right hand side you have 1.9599, which is rounded to 1.96. This is the value of critical value or Z score. And finally, if you have 99% level of confidence, click on second vars. You need to be on inverse norm. And then now change this to 99%. .99, 99. Mean must be 0, standard deviation must be 1, and then it must be located at the center. And when you hit paste, again, you see that you have 2.575 or 2.576, as the critical value that is located here on the slide as well. So you either memorize these or you use your calculator to find the critical value. Why it is important for us? Because we're going to use this information to find the margin of error. What is margin of error? If you have a level of confidence like C, 90%, 95%, 99%, the margin of error E, sometimes called the maximum error estimate, or error tolerance, is the greatest possible distance between the point estimate, which is in this case P hat, and the value of parameter, which is P population proportion. Now you can build the C confidence interval for population proportion P, which is given to you as P hat minus E and P hat plus E. The formula to calculate E, or the margin of error, is ZC times square root of P hat Q hat divided by N. Well, the probability that the confidence interval contains P is C, 90%, depending on question, 90%, 95%, 99%, and so on. So these values, these percentages, depends on the question that is given to you. You need to look for the percent. If it's not given to you, it is by default 95%. So you say that, hey, we are 90% confident that the estimation process is repeated a large number of times, and here you have the population proportion bounded between P hat minus E and P hat plus E. Let's take a look at an interesting example. In this example, you have a figure that has a survey of 498 US adults, and question says construct a 99% confidence interval for the population proportion of US adults who think that teenagers are more dangerous drivers. So when they did the survey of 498 US adults, 71% believe that teenagers are more dangerous drivers. 25% believe that people over 65 are more dangerous drivers. And 4% had no opinion, which is absolutely fine. Now, since from the information, we want to construct the confidence interval for population proportion of US adults who think that teenagers, so this is the key, teenagers are more dangerous drivers, it means that we're looking at 71%. From the figure, P hat, or the sample proportion, which is our point estimate, is 71%. So we can easily construct Q hat. Q hat is 1 minus 71%, which is 29%. Now what? What is the next step? In the next step, you're going to use ZC, P hat, Q hat, and N to find the margin of error. Remember the formula. E, or the margin of error, is equal to ZC, critical value for what? Critical value for 99%. It is 2.575 times square root of P hat, which is 71%, times Q hat, which is 29%. So you have your P hat, 71%, Q hat, which is 29%, divided by N, which is 498. If you do the calculation, multiply these two, it is about 5%. So the margin of error is about 5%. The distance between population proportion and sample proportion that you're calculating is at most 5%. Next, we need to find the left and right endpoint for 99% confidence interval. For the left endpoint, you have P hat minus E. So P hat minus E, which is approximately 71% minus this distance that you found, 5%. And on the right-hand side, you have P hat plus E, which is approximately 71% plus 0.05, which is just 5%. So if you do the algebra, P, or the population proportion, is bounded between 65.8% and 76.2%. So this is the interval that captures the true population proportion of US adults who think teenagers are more dangerous drivers. What's the interpretation? With 99% confidence, we are 99% confident that the population proportion of US adults who think that teenagers are the more dangerous drivers is between 65.8% and 76.2%. So this is the algebra behind it. How do you use your calculator, everyone? So remember that in this class, we're interested in using our calculator as often as we can. Let me share the screen and show you what to do. So first, you need to go to Stat, then go to Tests, and find one proportion Z interval. So again, one proportion Z interval is the one that you're looking for. Hit enter. What is X? What is N? What is confidence level? From the question, I only know it is 71%. So I need to make some adjustments here, everyone. I don't have the actual X value. I don't have the actual N value. I need to find those first. I actually know what N is. N is 498, but I don't know how many people exactly said yes. So what are we going to do? We're going to multiply 71% by 498. So 71% times 498 to gives us the exact X value. And here you have N, which is 498. There we go. The level of confidence is 99%. Let us do the calculation. Okay, let's see. We shouldn't have any decimal, so let us fix that. That's why you get an error. Let's go to tests again and find one proportion, Z interval. So this number should round up 353.53. That's why it cannot do the calculation for us. So let us round it up to 354. So out of 498 people, 354 said yes. So let's do the calculation now. Voila. Here you have the interval, which is on the left-hand side says I have 0.6585, which is very close to the number that you have on the left-hand side. And on the right-hand side, you have 0.76317, which is very close to the number that you have on the right-hand side. So you can use your calculator to calculate the confidence interval as well. But again, remember that in this scenario, we didn't have the actual X value. To find the actual X value, you have to do a little bit of algebra, everyone. So let me minimize this so you can see the full slide here with the interpretation and everything.